This is FE Peer Review. The date is May the 9th, 2021. I have a perspective question for Gary Wybenga. You did a video a few weeks back, Gary, that we've talked about. You had this diagram in your video. We could say that it shows a person standing at the North Pole, the bottom left, looking straight up above their heads. They see Polaris up in the sky. And then 690 miles away, following a line of longitude, we've got another person. They're standing at 80 latitude, and they look up and they see Polaris 10 degrees lower in the sky. And every 690 miles, every 10 degrees in latitude, drops 10 degrees. So we've got 10 people lined up, starting at the North Pole and ending at the equator. And they all look up at Polaris at the same time, and that's what they see. Fine, I'm fine with that. You say the further away you are from the North Pole, the lower on the horizon you will see Polaris, because it's simple perspective. So here's my question for you, Gary. I'm looking at this map of the Earth here, and I'm not concerned about how accurate or inaccurate it is. That's not really important. I just picked it because it's got some convenient latitude and longitude lines that are very clear and easy to read. Across the middle, there's a red line, that's the equator. Vertically down the center is a gray line, that's the Greenwich meridian. The lines are spaced 15 degrees apart, so going up from the equator, the next horizontal line is 15 latitude 15 north, latitude 30, 45, 60, 75, and then the North Pole at the top, and the same going down. The longitude lines are also spaced 15 degrees apart. So I double checked to 10, and we were talking about 10 degrees, not 15, so just keep that in mind with these lines. You were saying every 10 degrees, every 690 miles. So my question is, we have somebody standing at Greenwich, where the Greenwich meridian and the equator intersect. And now we place people every 10 degrees going along the equator. Let's take a look at this in Google Earth. There's the North Pole up here. And in your original video, we talked about somebody being at the North Pole and then coming down every 10 degrees. Every 10 degrees until they reach the equator. Well, this is a similar setup, but the difference I'm curious about, my question is this. We've got somebody down here where these equator and meridian meet, the prime meridian and the equator meet. And he's standing there on a little boat out in the water, and directly above his head there's a star. Now, obviously it's not Polaris, doesn't matter what star it is, but it's directly above his head. And then we go over 10 degrees, and 690 miles away there's another guy standing over here. And he's looking up towards the west, and he sees that same star. And then there's another guy 10 degrees further, and another 10, and another 10, 690 miles each one. These guys that are all lined up here, they're all looking at that same star. Do they see it 10 degrees lower in the sky, each one of them, compared to the last? That's my question for you, Gary. Basically, the perspective rule that you are saying applies to Polaris when you look north. Does that same rule apply if you're standing on the equator looking west, for example? A yes, it ought to be answerable with a yes or no answer, I think. I'd like to know what your answer is, and your explanation for the answer would be great. And if you can back that answer up with some math, you know that I love math. So let me know what you think, Gary. That's the question.